Hi everyone. Let's see the methods for separation of components of mixture. What are the important methods that I would like to discuss today? So first of all, the heading I am writing: methods for separation of components of mixtures. As we know, the matter is either pure substance or impure substance. The pure substances are elements and compounds. Impure substances are mixtures. So today we are discussing about the impure substances and how to separate the impure substances. That discussion we are going to do now. Some important methods, which are these? First of all, the filtration. I'll write here. Filtration is the one method. Then sublimation. Then distillation. Next one is fractional distillation. Another one is distillation at reduced pressure. Then steam distillation. Okay. Crystallization. Fractional crystallization. After to this, fractional crystallization. Then mechanical separation. It is carried out by using the separating funnel. Okay. Then there is a method like atmolysis. Then solvent extraction, gravity separation. So all these methods, their introductory information I'm going to give here. Yeah, so let's begin. The whole board is get filled completely. Just I'm trying. Yeah, let's see. First of all, mixture is nothing but the two or more components, either elements or compounds, or elements and compounds mixed together, and in between these components there is a certain force of attraction, which is not a chemical bond, it's a physical force of attraction is there. And most of the substances around us, practically most of the things, they come under the category of the mixture. Say for example, soil, a constructional material, even the marker board, and whatever the clothes we use, there is no any specific symbol or formula for these things, so that's why these are the mixtures. So mostly we are dealing with the mixtures, and it's easy as well as sometimes it's little bit challenging to separate the components of mixture. So some general methods of separation of components of the mixtures that I am discussing here briefly. First of all, and I guess you are aware with most of them or some of them, depends, but let's see. Filtration, what we do or for which purpose the filtration is used. The filtration is used, one of the component is insoluble solid and the another component is liquid one. So in that case, such a mixture is get separated by the method of the filtration. For example, sand, water, very common example. Beside this, silver chloride, AgCl, and water, and barium sulfate and water. So these are the water insoluble substances. So as to separate the silver chloride from water or barium sulfate from water, we can use the method of the filtration. Okay, I'm not going in too much details, just I said it's an introduction, so you should have a brief idea about the separation techniques. Okay, a lot can be stated. Yeah, The second one is sublimation, the process of conversion of the solid substance directly into the its gaseous form without going through the liquid state. That is the sublimation, and it occurs at a room temperature. So there are the sublimable substances, as we know: benzoic acid, salicylic acid, and iodine, then anthracene, naphthalene, camphor, okay, phthalic anhydride. All these are the examples of the sublimable substances. Suppose we have a mixture in which one of the component is sublimable and another component is a normal component, okay. So in that case, that mixture can be separated. Say for example, mixture of iodine and sodium chloride, okay. So iodine is sublimable, sodium chloride is not sublimable. So we should keep the mixture in certain say glassware, and we should keep the funnel over it, inverted funnel, so the sublimable substance will go up and it will get stick, it will adhere over the inner wall of that funnel, okay. Sometimes we have to increase little temperature, not too much, okay. Even though theoretically it is said that it is carried out at a room temperature. Another end of the funnel is to be seen, another end of the funnel is to be closed with the cotton, and here we have the mixture of the sublimable and non-sublimable substance. So iodine will get vaporized and it will adhere here, inner side of the funnel. Now the next one is distillation. Distillation is the method of separation of the liquids, in which suppose we want a pure liquid and certain impurity is present in the liquid, and the boiling point of the impurity and boiling point of the liquid which is to be obtained, that boiling point difference should be greater than 25 degrees Celsius. Mostly it is used for the separation of the liquid mixture, but liquid solid, they can also be separated by the method of distillation. So the example, say for example, we have the pure water and the sea water, and how to separate, how to obtain the only pure water. So we should provide the heat energy. The water, pure water, having a boiling point 100 degrees Celsius at standard temperature pressure condition, so water will get vaporized. So water vapors we should condense, and ultimately we'll get the pure water. So this is about the distillation. Now fractional distillation, some advancement is did here. Sometimes what happens, the difference between the component immiscible components of the miscible liquids, the boiling point difference is less than 25 degrees Celsius. So in that case, the fractional distillation method is used. A very common example is petrochemicals. So petroleum oil, that is crude oil, it is mixture of petrol, diesel, kerosene, naphtha, spirit, lubricating oil, paraffin wax, and so on. So the components of the petrochemicals, these fractions are get separated. They have the different range of the boiling temperatures. So at a certain temperature, that crude oil, when it is get heated, only we are going to get the certain specific vapors. But actually the difference in boiling points of these components, just I said, so these components, their boiling point difference is less. So that's why the certain specific arrangement is made, and some chambers are get used, and fractional distillation is carried out, okay. Now the next one is distillation. Here I wrote the example: crude oil components, these are get separated. Distillation at a reduced pressure. So sometime what happens, that liquid which is to be obtained in pure form, it get decomposed before reaching its boiling point or near to its boiling point. The well-known example is of the hydrogen peroxide. We have the mixture which consists of the hydrogen peroxide, and we want the hydrogen peroxide. We are heating the mixture and we are getting the hydrogen peroxide at its boiling point. We are expecting it, but at its boiling point, hydrogen peroxide is get decomposed. So what to do in this case? Are you understanding? So here we have kept the hydrogen peroxide and some other things are there. We are giving the temperature, heat energy to it. Hydrogen peroxide is get vaporized, but at the boiling point it is going to decompose. So in that case, we should reduce the pressure. So what will happen? So if we keep here whatever the atmospheric pressure earlier, so we should reduce the pressure artificially. So because of this, hydrogen peroxide will boil at the lower temperature. Okay, and so less energy will be required for the hydrogen peroxide liquid molecules to get vaporized, and that's why it will get boiled at a lower temperature. Okay, and this method is nothing but the distillation at a reduced pressure. So we will get the pure hydrogen peroxide vapors, and on again condensation will get here the pure hydrogen peroxide. Now steam distillation. Steam distillation is used when the component of the mixture, one of the component of the mixture is water soluble. So we should say, for example, here we have the mixture, and one of the component like a nitrobenzene, aniline, sandalwood oil or lemon oil. Okay, one of these components, say for example sandalwood oil is present here, and other components are the insoluble in water. So we should heat this mixture in the flow of the steam. Okay, so when the steam and that mixture come in contact with each other, that the component, say for example sandalwood oil, it get dissolved in that steam. It will get mixed with the steam, and along with the steam it come out, only the that sandalwood oil will come out, and from the water we can separate it again. Okay, so that's the steam distillation. Another method is the crystallization. There are the various ways to form the crystals. Say for example copper sulfate aqueous solution we have. So either by using magnetic stirrer or providing the heat energy, or we should keep that aqueous solution or any other solution into the under the high temperature, high pressure in the autoclave we may keep. So the crystalline solid, if it is there in a liquid state, so we can make available the crystalline solid again back. Okay, either by stirring only or providing heat energy or mechanical force. That's the crystallization. Crystals are to be allowed to form. Here I give the example of the copper sulfate, which is to be obtained from its aqueous solution. Then there is a fractional crystallization. What is the fractional crystallization? Suppose we have a mixture, say for example KCl and KClO3, okay, or Na2Cr2O7 and Na2SO4. This mixture we have. So amongst this potassium chloride and potassium perchlorate having the less solubility, potassium chloride having the high solubility. Okay, so what we have to do? Suppose water we took, we have added the KCl and KClO3. So KCl is more soluble, KCl is completely soluble in water, KClO3 is partially soluble. So we should decrease the temperature, solubility of KClO3 again get decreased, and only the KCl will remain in the solution form, okay, in the aqueous form, and remaining fraction will not be remain in a that aqueous form. Okay, now another example, Na2Cr2O7, potassium dichromate and potassium sulfate. Here the potassium sulfate is less soluble in water and potassium dichromate is more soluble. Okay, so that mixture is to be dissolved in cold water. The component which is the component of the mixture which is more soluble will get dissolved early. Okay, then separating funnel we should use. Separating funnel looks like this. Here it is a glassware. Downside here we have the knob, and here we have to take the mixture. So water and oil, as oil generally it is having lesser density, it is going to float over the water. So what we should do, we should rotate this knob. First of all we'll collect the liquid, that is nothing but the water. The main thing is that at the junction of water and liquid, we have to that part when it comes here, so we should discard little part. Okay, we should not completely separate the water and oil exactly. So this junction part when it comes here, we should discard some part, and again in the another container, another beaker, we should collect the oil. So that is the mechanical separation. Next one is atmolysis, so as to separate the mixtures of the gases like H2 and O2. Immiscible gases are there, N2 and Cl2. Okay, the gases which are not forming a chemical bonds at a room temperature, such a gaseous mixtures can be separated by the method of atmolysis based on the Graham's law of diffusion. Okay, the diffusion based on the Graham's law of diffusion, these are get separated. That's the atmolysis. Solvent extraction means what? Say for example, that component we have, okay, we have the mixture of iodine and sodium chloride, and we want only the iodine. Okay, we can use method either sublimation, or here what we can do, we can put either chloroform CHCl3 or carbon tetrachloride CCl4 in this mixture. What will happen? Iodine specifically will get dissolved into the that chloroform or carbon tetrachloride. So iodine having more solubility in these solvents, and it will get dissolved, and from that volatile solvent we can re-obtain the iodine. Okay, are you understanding? So iodine sodium chloride mixture we are pouring this solvent like a carbon tetrachloride, iodine will get dissolved, and that iodine can be that's when the solvent is get evaporated or again get collected, only pure iodine we can get. And gravity separation method, so as to separate the specifically, suppose we have the oxide ore, hematite ore, Fe2O3 hematite ore, and some impurities are present. What we should do, that hematite ore is allowed to pass through the sloping platform. Here we have taken the ore, and here there is a sloping platform. Here there is a running stream of water. So along with the ore, that impurities are also passing there. Okay, impurities are lighter. Generally the impurities are lighter, so the lighter impurities passes along with the water. So here we are collecting the impurities. These impurities are known as the gauge or matrix, and here we have the heavier ore particles, and here we are keeping the wooden rifles. Okay, so what will happen, these heavier ore particles, because of their higher density, they'll get collected here, they'll get trapped here in the wooden rifles, and lighter gauge particles, they are flowing here. Okay, now they are flowing along with the water. So in this way, the oxide ore, especially hematite ore Fe2O3, magnetite Fe3O4, okay, zincite Zn cuprite Cu. So like that, ore and its impurities are get separated by the gravity separation method. Okay, so very briefly I try to sum up the introductory part of the separation of component of the mixtures. Okay, bye, thanks a lot.